Hi everyone, this is Samit Sankanavar. I welcome you all to my channel Mathshala. After a long time, I am back with detailed revision series video, and in this session, I will be discussing on one of the most important chapter of SSLC mathematics, that is quadratic equations. The contents of this video are going to be: first, I'll give a brief introduction about quadratic equations. Then I'll explain formation of quadratic equation based on any given problem statement. Then we will look into the solution of a quadratic equation by factorization method. After that, we will look into the solution of a quadratic equation by completing the square method. Then we have one more method of solving quadratic equation, that is by quadratic formula. Then coming to the last point or last subtopic, that is nature of roots of quadratic equation. These are the contents of today's discussion. Let us go ahead with the introduction first. From my previous videos, you might have come across terms called as linear equations. Now, what are these quadratic equations? In order to have a better understanding of these quadratic equations, I would like to go back to my first video of this detailed revision series, wherein I have explained in detail about the polynomials. And if I pick one particular point from that chapter, that is, polynomials of degree 1 are called as linear polynomials, and polynomials of degree 2 are called as quadratic polynomials. Similarly, polynomials of degree 3 are called as cubic polynomials. Here, we do not have any discussion about the cubic polynomials. Regarding linear polynomials and linear equations, we have discussed in my previous video, wherein I have explained about the chapter pair of linear equations in two variables. And coming to this chapter, we are going to talk all about the quadratic polynomials. Here in this quadratic polynomials, degree of variable is going to be equal to 2. In order to understand in a further better manner, I'll take that when quadratic polynomials are equated to 0, they are called as quadratic equations. This chapter is all about quadratic equations. In order to have a equation, that polynomial has to be equated to some particular term, and that particular term, when it is equated to 0, that polynomial become quadratic equation. General form of polynomials of degree 2, or I can say quadratic polynomials, is given by ax square plus bx plus c. This I have explained in detail in the polynomials chapter. Here a cannot be equal to 0. If a becomes equal to 0, this entire term becomes 0, as it is the coefficient of x square. If this term becomes 0, then this polynomial will no longer remain as a quadratic polynomial, that will reduce to linear polynomial, where degree of variable will be only 1. That is when a becomes equal to 0. Therefore, this a cannot be equal to 0 in order to this polynomial to exist as a quadratic polynomial. Now, if I equate this quadratic polynomial to 0, that will become quadratic equation. Therefore, standard form of a quadratic equation is ax square plus bx plus c is equal to 0. Again, here a cannot be equal to 0. Now, let us look into the examples wherein how we can identify whether the given equation is quadratic equation or not. In your exercise 1, there are few questions given in this manner, and he has asked you to verify or identify whether this given equations are quadratic equations or not. Out of those problems, I am picking this one example for understanding. When I simplify this equation, you can see in the first term it is x minus 2 whole square. This is of the form a minus b whole square. When I expand this bracket here, it will be a square minus 2ab plus b square. That is equal to 2x minus 3 as it is. Here, instead of a it is x, instead of b it is 2. When I further simplify this, x square I'll keep as it is. 2x into 2 will be 4x plus 2 square is 4 here, and when I bring this terms on the left hand side, it will be plus 2x will become minus 2x and minus 3 will become plus 3, and that is equal to 0. When I further simplify this, x square minus 4x and minus 2x is minus 6x, 4 plus 3 will give me 7. Now This equation is of the form quadratic equation. You can verify here. There is one x square term and there is x term present here. And in this case, coefficient of x square is 1. If there is nothing next to x square term, that is nothing but 1. Then coefficient of x is minus 6 and constant term is 7 here. Therefore, we can say that this equation forms a quadratic equation. Going ahead with the next subtopic of this video, that is formation of quadratic equation. In this slide, I'll explain about creating quadratic equation based on the problem statement given. Let us look into the examples to understand it in a better way. First, I'll consider the first example, that is the area of a rectangular plot is 528 meters square, and he has mentioned that length of the plot is one more than twice its breadth. Now we need to find the length and breadth of the plot. Let us understand this in a simple way. Here, area of rectangular plot is given as 528 meters square. And we know that area of rectangle is nothing but length into breadth. Here, L is equal to length of the plot and B is width of the plot. Now, according to the statement given in this problem, he says that length of the plot is one more, that is one more than twice its breadth, that is nothing but two times its breadth. That is, if I want to write it in the form of equation, L is equal to 1 more than 2 times of its width. First I'll write 2 times of width plus 1 I'll add to that. That will complete my statement which is given here for the length of the plot. Now, substituting this in this formula of area of rectangle, we know that area of rectangle is length into width. In place of length, I'll substitute 1 plus 2b and into b as it is. That is equal to 528 because area of rectangular plot is 528. Now, when I multiply this b inside the bracket, I'll get b into 1 is b plus as it is 2b into b is 2b square, that is equal to 528 here. Now 2b square plus b minus 528, when I rearrange this equation, that will become 2b square plus b minus 528 is equal to 0, which is of the form you can observe here ax square plus bx plus c is equal to 0. You can observe that here instead of x square it is b square, because variable can be any alphabetic English alphabet, that is A, B, C up to Z, anything it can be. But generally we represent it as x square. In place of x square it is b square, in place of x it is b, and in place of c it is minus 528. Here coefficient of b square is 2, coefficient of b is 1, and constant term is minus 528. Therefore, this is a quadratic equation. Coming to the next question, one more example I have considered here. It says the product of two consecutive positive integers is 306. Now we need to find the integers here, those two integers. Let x be the one positive integer. Now next consecutive positive integer will be one more than that. That is nothing but x plus 1. For example, one positive integer is 2. Then next consecutive positive integer will be 3. That is nothing but one more than that. If 20 is my positive integer, next consecutive positive integer will be 21. Like that, if x is the positive integer, next consecutive positive integer will be x plus 1. Now, according to this statement, product of these two integers, that is nothing but x into x plus 1 is equal to 306. When I simplify this, I'll multiply this x inside this bracket. That will be x square plus x is equal to 306. When I get this 306 on the left hand side, it will be x square plus x minus 306 equal to 0. If you compare, even this is of the form ax square plus bx plus c is equal to 0. Therefore, this is the method how we can arrive at the quadratic equation based on the given problem statement. Now that we have understood formation of a quadratic equation, going to the next step, now we need to solve that quadratic equation and arrive at a solution. In order to find the solution of a quadratic equation, there are mainly three methods that we are going to look into this chapter. Out of that, first method is going to be the method of factorization. In order to understand solution of a quadratic equation in a better manner, I would like to go back to previous chapter, that is polynomials. You might have come across a term called as zero of a polynomial. Note that zeros of quadratic polynomial ax square plus bx plus c and roots of the quadratic equation are nothing but the same. If you want to look into the term zero of a polynomial, if I explain that further, zero of polynomial, zero of any polynomial is that one particular term or a number which upon substituting in that polynomial, if value of that polynomial is going to be equal to zero, then that term or number is called as zero of that polynomial. And one more important result we have, that degree of that polynomial is equal to number of zeros, which means in case of quadratic polynomial you will have two zeros, means there will be two such numbers which we can substitute in this equation, wherein I'll get answer as 0 when I simplify them. Likewise, those two zeros are nothing but roots of the quadratic equation. Means you, after solving this quadratic equation, you will get always two such numbers upon which substituting in this equation equation, that equation will reduce to 0. If I want to further explain, in general, a real number alpha is called root of the quadratic equation ax square plus bx plus c equal to 0 if a alpha square plus b alpha plus c is equal to 0. Nothing but that number, that is any particular number, I can say it as alpha. When I substitute that alpha in place of x, that upon solving that particular equation, that should be equal to 0. We also say that x equal to alpha is a solution of the quadratic equation. Means by replacing x by a particular number that I say alpha, getting answer as 0. Therefore, I call this alpha as solution of the quadratic equation. Or x satisfy, I can also say that alpha satisfied the quadratic equation. General form of quadratic equation is given by ax square plus bx plus c is equal to 0. Then, in order to solve a quadratic equation by factorization method, I need to split this middle term, that is b into x, in such a way that product of the split terms should be equal to product of coefficient of x square and the constant term. That is nothing but product of a into c, or product of a and c should be equal to product of the two split terms which is obtained by splitting this b term here. If I simple manner with an example, that is one example 1 I am considering here. Find the roots of the equation 2x square minus 5x plus 3 is equal to 0 by factorization method. Now, as I mentioned in the previous slide, in order to arrive at a solution by factorization method, the middle term, that is 5, if I closely have a look at this and comparing it with the standard form of quadratic equation, this is minus 5. Value of b here is minus 5. If I want to mention that, then I need to split this minus 5 in such a way that that should be equal to product of a and c, that is nothing but 2 into 3. Product of a and c is 2 into 3, that is 6. Then product of split terms. Now minus 5x I can split as minus 3x and minus 2x. Writing minus 5x is same as that of writing minus 3x minus 2x. Therefore, when I split this minus 5x as minus 3x and minus 2x, I'll get product of these two terms again. If you see, that is same as a and c product. Therefore, I can split this given quadratic equation in this manner, that is 2x square minus 3x minus 2x plus 3 equal to 0. Now, in this two terms, you can see x is common. So I'll take x out. Then inside it will be 2x minus 3 here. and in these two terms, if I take minus 1 as common, inside bracket it will be 2x minus 3, then it is equal to 0. Now we have two terms here, x into 2x minus 3. One more term is minus 1 into 2x minus 3. Among these two terms, again, you can see that 2x minus 3 is common. In that case, if I take 2x minus 3 outside, inside bracket I will have x minus 1. If you solve this again by multiplying each term by other term, again you will arrive at the same equation. That is just solved in a reverse manner. Now, if you observe here carefully, there are two terms inside the bracket, which means that is equal to 0, which means that product of these two terms is equal to 0. If upon multiplying any two terms, I am getting answer as 0, means one of these terms should be equal to 0. I am not sure whether this term is 0 or this term is 0, because of which their product is becoming 0. So what I'll do, I will equate these two terms separately to 0. I'll say either 2x minus 3 is equal to 0 or x minus 1 is equal to 0. That is when I'll get answer as 0. Therefore, when I simplify this, I get x value as 3 by 2 or x value as 1. As I mentioned earlier in the previous slide, we will have two solutions of x or of that quadratic equation. That is nothing but two roots. That is nothing but again two zeros of this quadratic equation. These are nothing but the zeros of this quadratic equation, which means upon substituting these values of x in this equation 2x square minus 5x plus 3, you will definitely get left hand side as 0, because already right hand side is 0. That is LHS equal to RHS. Therefore, these two terms are called as zeros of this polynomial or zeros of this equation, or also called as roots, or I can say that these two are the solutions of this quadratic equation. Let us take one more example to have a better understanding of solution of quadratic equation by factorization method. So I'll take one more example, that is example 2, which says find the roots of the equation 3x square minus 2 root x plus 2. If I compare this equation with the standard form of quadratic equation, it coefficient of x square, that is generally a, which is equal to 3, coefficient of x is minus 2 root 6, and constant term is 2 here. Let us understand how we can split this. For factorization, middle term should be split in such a way that product of split terms is equal to the product of a and c terms. Here a and c terms are 3 and 2, that is nothing but product. When I consider 3 into 2 is 6. I need to split this minus 2 root 6 in such a way that after multiplying them I should get answer as equal to 6. Let us see how we can split. 3x square I will keep as it is, because I just have to split the middle term, that is minus 2 root 6. If you can see here, 2 root 6, that is nothing but I have two apples. So 2 apples I can write as 1 apple plus 1 more apple. Similarly, 2 root 6 is nothing but 1 root 6 plus 1 more root 6. Therefore, here it is minus sign. Minus 2 root 6, I can write it as minus 1 root 6 and minus 1 more root 6. When I add these 2 root 6, when I add this 1 root 6 plus 1 more root 6, I'll get minus 2 root 6 here. Then you can see product of these two terms, that is root 6 into root 6, I'll get root 36, that is nothing but 6, which is equal to product of a and c terms, that is 3 into 2 equal to 6. You can see here a and c is nothing but 6. Product of split terms is also minus root 6 into minus root 6 is plus root 36, that is nothing but 6 again. Now going ahead, root 9 is nothing but 3 here. What I have done is 3 I have expressed in terms of root 9 here. We already know that root 9 is again 3. Why I have done this? Uh, I'll just explain in my next step. Again, root 6 minus root 6 I have kept as it is. Minus root 6 x again I have kept as it is. And 2 I have represented it as square root of 4. Now it becomes very easy to take common in these two terms. That is the reason why this 3 is expressed in terms of root 9 here. Therefore, among these two terms, if I take root 3x as common, in bracket I'll have root 3x. So if you can see here, if you multiply these two terms again, you will get root 9 x squared. Root 3 into root 3 is root 9, x into x is x squared. Minus here I have taken out root 3x. Root 3x into root 2 will be root 6x. Here also in these two terms, I can take root 2 as common. So I have taken minus 2 root 2 as common. When I multiply this with, when I take out root 2 common from root 6x, that will be root 3x. And here it is plus. So minus into minus will become plus. Therefore, I have taken it as minus 2 root here. You can see among these two terms again, root 3x minus root 2 is common. When I take that out, one more I can say root 3x and minus root 2 I'll have here. Now, if these two product of these two terms is equal to 0 here, then either this should be 0 or this should be 0. So I will equate root 3x minus root 2 equal to 0. Therefore, I get answer as x equal to root 2 by root 3, or I can generally represent this as x equal to root 2 by 3. Here x equal to root 2 by 3. Earlier I mentioned that for a solution of quadratic equation there will be always two roots, and we know from polynomials that degree of that polynomial will be equal to number of zeros of that polynomial. Here both the roots are equal, that is same number will have to be substituted in this equation in order to arrive at a solution, that is x equal to 2 root 2 by 3, and one more root is again x equal to root 2 by 3 here. Hope you understood this factorization method. The splitting of terms, how we can do this will come with experience and with practice. So do practice more and more problems on this chapter of solution by factorization method in order to have a better command over splitting of middle terms in order to arrive at solution by factorization method. Next method of solving quadratic equation is by completing the square method. In order to understand this method, it is very essential to have basic knowledge of these two formulas here, that is a plus b whole square is equal to a square plus 2ab plus b square, or a minus b whole square is equal to a square minus 2ab plus b square. Basic idea of solving by this method is nothing but whatever given quadratic equation we have, first we will convert them to bring to standard form. Like our target will be to bring given quadratic equation to any of the above form, depending on whether plus sign is present in the quadratic equation or it is minus sign. We'll understand this method considering one example here. Solve 2x square minus 5x plus 3 equal to 0 by method of completing the square. Here, what I will do is first I'll compare this given quadratic equation with the standard form of quadratic equation. That is nothing but ax square plus bx plus c is equal to 0. When I compare this, I get terms, that is coefficient of x square as a, that is nothing but 2 here. Coefficient of x is b, that is nothing but minus 5 here, and the constant term c is equal to 3 here. Now I have these three terms. Why I noted down these three terms, you will understand in a short while. Step 1. To proceed solving this quadratic equation by completing the square method, I have divided this entire procedure in several steps. Step 1. Our target will be to convert the a term, that is nothing but coefficient of x square, to a perfect square in case it is not a perfect square. If coefficient of x square is a perfect square, then our step 1 is not valid. We'll directly jump to the second step. But here in our case, coefficient of x square is not a perfect term. First, I will convert this to a perfect square. If you carefully observe this here, this form, like this quadratic equation, we can reduce to this form. as I have a minus term here and one minus term here, plus term here, one more plus term here, a square here, instead of that x square I have, and a is there, x is there, b square is nothing but one particular number and it's a square, that I can make some adjustment and convert this quadratic equation to this form. So my first target is I need to have a square term here. That is nothing but if I make this coefficient of x square as a perfect square, then these two terms together I can put it in a bracket and have a square of that. That will become my a term, which I can reduce to a here in this square formula. Let us see how we can do that. In order to convert this coefficient of x square to a perfect square, here if you observe, a term is 2, so nearest square term will be 4. That is, nearest perfect square is 4. If I have to make this as 4, I have to multiply by 2. Then I cannot multiply 2 to only this term. I have to multiply it throughout the equation. Therefore, multiplying the equation throughout by 2. When I do that, I'll get 2 into 2 is 4 x square as it is, minus 5 into 2 is minus 10 x as it is, 3 into 2 is 6, then 0 into 2 also have to make, but 0 into any number is again 0. Therefore, whatever multiplication I do on this side, that may not have any changes on the right hand side. Now, coming to the second step, if you carefully observe a minus b whole square formula, here term a square I need to make. So now that I have 4x square here, can I represent this 4x square as 2x whole square? Which means my a term will be equal to 2x here. Now, here only I'll jump to the next term now, that is 2a into b. If I have fixed my a term, if you carefully observe here, a term that should be 2x. So I will take that 2x out from this 10x. When I take that 2x outside, this is my a term. Now I am left with 2 and b. Somehow I need to bring one 2 there, and b term will be decided based on that 2. Means how I am making that adjustment. Later I will decide which is going to be my b term. Then this 6 I'll keep as it is. Once I have that b term, then I can take square of that term and I'll make that adjustment to bring b square term. Now you can observe here 2x square I have kept as it is. In order to introduce this 2, in order to introduce this 2 here in this equation, what I have done is I have multiplied this 2x into 5 by 2 and I have divided by 2. I have multiplied by 2 and again I have divided by 2. Just that I have brought this 2 here below 5. This is nothing but again same. Imagine I have 6 rupees. I will multiply that 6 by 2. That will become 12 rupees. Again I will divide that by 2. That is again coming to the same answer, that is 6. So multiplying a particular number by a x number and again dividing that by again x number will not make any difference. Therefore, in order to introduce this 2 here in this equation, what I did is I multiplied these two terms by 2 and again I divided it by 2. But only adjustment that I have made is that denominator 2 I have brought it and kept below 5 here. Now you can carefully observe, if you observe this term, it looks similar to this term, that is 2ab. So that I have my 2 term here. A term already I know that is 2x. B term now you can see it is looking something like 5 by 2. Therefore my B term I have fixed now 5 by 2. Now I need to introduce B square term. I will just add this B square term and I'll again subtract this term. When I add and subtract same term to any equation, again I am not making any changes here. I'm just making this adjustment so that I'll bring b square term here. And this plus 6 I am keeping as it is. Now you can see a minus b whole square is equal to, if you carefully observe these terms here, this is a square minus 2a into b plus b square. Here b is 5 by 2, a is 2x and this is 2ab term. Therefore, this term I can completely represent as a minus b whole square, that is nothing but 2x minus 5 by 2 whole square. When I expand this again, I'll arrive at this expression itself. I have simplified this and I have kept it as 2x minus 5 by 2 whole square. Now, what about these terms? These terms I will simplify and I'll keep them as this. That is 5 by 2 whole square will be 25 by 4 plus 6 as it is here. Then 2x minus 5 by 2 whole square as it is. When I simplify this further, I'll take 4 as LCM and it will be minus 25 plus 4 into 6 is 24 here. Therefore, when I solve this, 2x minus 5 by 2 whole square is equal to minus 1 by 4 here. When I bring that minus 1 by 4 to other side, that will be plus 1 by 4 here. Now, in order to remove this square, because I want to get x value, if I want to solve the x value, first I need to remove square as per the BODMAS rule. BODMAS rule says first I have to solve bracket, then I have to solve order, then I have to solve division, multiplication, addition, then subtraction. So what I'll do is if I want to go reverse of that rule, I'll have to first get rid of this order term here. For that, what I can do is taking square root on both sides. When I do that, I'll get square root and square get cancelled. Therefore, 2x minus 5 by 2 is equal to square root of 1 by 4. Now you know that square root of 1 by 4 is, it can be either plus 1 by 2 or it can be minus 1 by 2. Therefore, when I take this minus 5 by 2 on the other side, it will be 2x equal to plus or minus 1 by 2 and this minus 5 by 2 will be plus 1 by 2 here. Then x equal to, I can bring these two down here in order to get answer for x. That will be x equal to 5 by 4 plus or minus 1 by 4. I will have two solutions here now. If I consider this as plus 1 by 4, it will be 5 by 4 plus 1 by 4, that is nothing but 6 by 4. When I further simplify this, it will be 3 by 2. Or if I take 1 by 4 as minus, it will be 5 by 4 minus 1 by 4, that is nothing but 4 by 4. Again, nothing but x equal to 1. So I arrive at two roots of this given quadratic equation, that is nothing but 2 by 3 or x equal to 1. Now you can see here that these are the two zeros of this given quadratic polynomial, or I can say quadratic equation, or these two are the solutions of these two, this given quadratic equation. You can verify that by substituting these values in this quadratic equation and check whether you are going to get answer as equal to 0 or not. This method is bit complicated, but when you practice it multiple times, you will easily understand this method and it will become very easy for you to solve. You cannot avoid this method as examiner can ask anything. He may particularly mention that solve this given quadratic equation by completing the square method itself. So have a clear understanding of this method as well. This is bit tricky and bit complicated method compared to first method that we solved by factorization, and one more method we have next as quadratic equation method. Hope you understood this. With this, I will take one more example for having a better picture of this method. Let us understand this method by one more example. So these two statements will, I'll keep them as it is like from the previous slide so that you will have better understanding. Next example that I have considered here is solve 5x square minus 6x minus 2 equal to 0 by method of completing the square. So as I mentioned earlier in the previous slide, first we'll compare this with the standard form of quadratic equation, that is ax square minus ax square plus bx plus c equal to 0. Here if you compare, I'll get a value that is coefficient of x square as 5, b value that is coefficient of x as minus 6, and c value that is constant term as minus 2 here. If you carefully observe, I can reduce this quadratic equation in this form, that is a minus b whole square equal to a square minus 2ab plus b square. If I have a plus term here, then I can reduce it to this form. But it is easier here to convert to a minus b whole square. Therefore, I'll consider this one. What we have to do first step, as I mentioned earlier, first we have to look into the coefficient of x square. If this is a perfect square already, then no need to take this step. As it is not a perfect square now, first what I'll do is I'll convert this to a perfect square. If I have to convert this to a perfect square, nearest perfect square for this phi number I'll get is 25. Means when I multiply this phi by 25, by multiplying any number, if I am getting a perfect square, that is fine. But there is no such number which will give me a perfect square to multiply with 5. Therefore, I'll consider it as 5 only. So when I multiply this equation throughout by 5, I'll get coefficient of x square as a perfect square, that is nothing but 25 square, 25 x square. Then when I multiply that 5 to 6, 5 into minus 6 is minus 30, 5 into 2 is minus 10 here. Now that I have a perfect square here, I will represent this as a minus b whole square is equal to 5x whole square. As I did earlier in the previous method, it is 5x whole square minus, now I know that a term here, I will take out that a term from this entire 30x. When I take out that a term, that is minus 5x outside, 6 will be remaining here. In order to introduce this 2, what I do is I'll multiply by 2 and again I'll divide by 2. As I told earlier, when I multiply and divide by a same number, it has no impact on this equation. It is just for making adjustment or to bring this 2 in this equation. And minus 10 I am keeping as it is. Now you can see here a term is I have got as 5x here, that I have put it inside the bracket and it is square here. Therefore a minus b whole square is equal to 5x whole square minus, you can see this 2 term is there, that is nothing but this 2, this is a and this is b, but this 2 is there. When I divide this 6 by this 2, it will be 3. Therefore my b square, now my b term is nothing but 3 here. Earlier it was 5 by 2 in previous example. Now that I can easily cancel this 6 by 2, I'll reduce it to 3 here. Therefore my a term is 5x and b term is 3. In order to introduce this b square term, so I will add by 9 and I'll again subtract 9. So that is nothing but b square. B is 3, 3 square is 9. I'll add 9 and again I'll subtract 9. It will have no impact on this equation as I'm adding and subtracting the same number. This is just to make the adjustment. Once again I repeat. Then this minus 10 I'll keep as it is. Now you can see that whatever this highlighted part in the green portion, that will give me a minus b whole square formula. Here a is my 5x and b is 3. A 5x square, that is a square, minus 2, a is 5x, b is 3 and b square is 9 here. Therefore I'll represent this whole green part in 5x minus 3 whole square minus this minus 9 and minus 10 is minus 19 here. When I simplify this, I'll bring this minus 19 on the other side, that will be plus 19. Now taking square root on both sides in order to get arrive at the final answer for x, I need to simplify this. Taking square root on both sides in order to remove this square here, what will happen? Square root and square get cancelled. I'll be left with 5x minus 3 equal to square root of plus 9 plus root 19 or minus root 19. When I take square root, it can be either plus or it can be either minus. Therefore 5x is equal to this minus 3, I'll bring it on the other side, it will be plus or minus root 19 plus 3 here. Or if I just want to keep x on the left hand side, I'll bring this 5 on the right hand side, it will be 3 plus 19 by 5, because I can have two values here, 3 plus root 19 by 5 and 3 minus root 19 by 5. These are the two roots of this quadratic equation here. Or I can say these are the two zeros of this quadratic polynomial, or this is solution to this quadratic equation. You can cross verify by substituting this values of x in this quadratic equation and check after solving this whether you are getting answer as 0 or not. Hope you understood this method of solution of quadratic equation. This is, as I mentioned earlier, again bit complicated. Do practice this method by taking similar examples and have a better understanding. Now I'll move ahead with next method of solving this quadratic equation, that is quadratic formula. Solution of quadratic equation by quadratic formula. This is the easiest method of solving quadratic equations. Let us see how we can do that. It is given that if b square minus 4ac term, what is b square? B is nothing but coefficient of x, a is coefficient of x square, and c is the constant term. When I consider this form, that is b square minus 4ac, for a given quadratic equation of this standard form, if it is greater than or equal to 0, then I can get solution of quadratic equation applying quadratic formula. That quadratic formula is given by x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Now you might have a question, why this greater than or equal to 0? If you can observe here, this term in this formula comes out to be inside a square root here. If it is equal to 0, then square root of 0 is 0. If it is greater than 0, square root of any positive number greater than 0 means that is a positive number. That will be a real number. In case this b square minus 4ac term is less than 0, then square root of a negative number does not exist as a real number. It will be a imaginary number. Therefore, right now in class 10 you don't have concept of imaginary numbers, so you need not worry about that. Only thing you need to remember is b square minus 4ac should be greater than or equal to 0 here. Now this is the quadratic formula that we have. Now what we have to do is, this formula for finding the roots of quadratic equation is known as quadratic formula. Remember that if in question anywhere it is asked, write quadratic formula, you need to write this formula. We'll understand solution to this quadratic equation by formula considering an example here. This is the same example as I considered earlier in this video. The area of a rectangular plot is 528 meters square. Length of the plot is one more than twice its breadth. Where we need to find the length and breadth of the plot. Let x be the breadth of the plot, then length is nothing but, he is telling that 1 more than 2 times of its breadth. 2 times of its breadth plus 1, that is nothing but length. Now we know that area of plot is equal to length into width. Length is 2x plus 1 into width is x. So when I simplify this and arrive at this equation, that is 2x square plus x minus 528 equal to 0. This is my quadratic equation now. Now when I compare this with the standard form, that is ax square plus b plus bx plus c equal to 0, I will note down all the coefficient values. That is, coefficient of x square is a equal to 2, coefficient of x is b is equal to 1, and constant term c is equal to minus 528. Now it is very simple that take all these values and just substitute them in this quadratic equation, that is x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. When I substitute that, in place of b, it will be 1 here, plus or minus square root as it is. B square is nothing but 1 square, minus, in place of 4, I'll keep 4 as it is. In place of a, I will put 2 here. In place of c, I will put 528. Since c is negative, I'll put it in a bracket so that it will not create any confusion further. Then whole divided by 2 into a. Here a is nothing but 2 again. Just go on further simplifying this. Minus 1 as it is, plus or minus I will keep as it is. Square root of 1 square I will keep as it is. First I will solve this term. Minus into minus will be plus. 528 into 4 into 2. When I do this multiplication, I will get 4224 here. Further simplifying this, 1 square plus 4224, that is nothing but minus 1 I'll keep as it is, plus or minus. Inside this square root, it is 4225. Whole divided by 2 into 2 is 4 here. Then x equal to minus 1 plus or minus Square root of 4225 is nothing but 65 here. Then if I consider this 65 to be plus, that will be my one root. When I consider this as minus, that will be my another root. So when I consider this as plus 65, it will be 65 minus 1, that is 64 divided by 4, that is nothing but 16. Therefore, x equal to 16 is the first root. When I consider this 65 to be minus, that will be my second root, that is nothing but minus 1 minus 65 is equal to minus 66 divided by 4. When I further simplify this, it will be minus 33 by 2. Therefore, now I have two roots of this given quadratic equation, that is 16, and one more is minus 33 by 2. But one thing you can uh, remember here is in this given question, we have assigned x to be breadth of the plot. Remember that width cannot be negative number. Therefore, x, that is nothing but width of this plot here, is 16. No doubt we are getting two solutions here, but we need to pick the right solution to solve our daily problems. No doubt substituting these two equations, these two values of x in this quadratic equation, I will get answer as 0. But we cannot use this value of x, as width cannot be negative. Width will always be positive. Therefore, x equal to 16 is the correct answer for width. When I substitute x equal to 16 in this equation, I'll get width and length of this plot. Hope you understood how we can solve this problem by quadratic equation. I'll consider one more example here. Next example on quadratic formula, that is find two consecutive odd positive integers, sum of whose squares is 219. Let us note down the given data. Let x be any odd positive integer. As he has mentioned, odd positive integer. Let x be any odd positive integer. Next consecutive odd integer will be 2 more than this x. For example, I am considering 23 as my odd positive integer. Next odd positive integer will be 25. That is nothing but 2 more than the previous one. Therefore, if I consider x to be the odd positive integer, next consecutive odd integer will be x plus 2. This you can see here. Now, as per the given statement, sum of whose squares? Sum of square of these two numbers is 290. Therefore, sum of square of these two numbers, sum of square of these two numbers, I repeat here. Therefore, that is equal to 290. When I simplify this by expanding this bracket, a plus b whole square here, x square I'll keep as it is, plus a square plus 2ab, that is 2 into x into 2, plus b square. B square is 2 square, that is nothing but 4. When I further simplify this, I'll get x square plus x square as 2x square, plus 2 into 2 is 4, x as it is, 2 square is 4 here, and this 290, when I bring it on the left hand side, it is minus 290. That is equal to 0. 2x square plus 4x plus 4 minus 290 is equal to minus 286 equal to 0. I'll take 2 common here from this entire equation. Then it will reduce to x square plus 2x minus 143 is equal to 0. Comparing this quadratic equation with standard form of quadratic equation, that is ax square plus bx plus c equal to 0, I will note down a value that is equal to 1, b value that is coefficient of x equal to 2, and c value that is constant term to be minus 143 here. Now I'll just consider the quadratic formula, this one, and I'll substitute all the values of a, b and c in this equation, and I will get the solution in the form of x. Therefore, x equal to, in place of b, I'll put 2, that is minus 2 plus or minus square root of b square is nothing but 2 square minus 4 as it is. A value is 1 and c value is minus 143 here. Therefore, x equal to minus 2 plus or minus square root of 2 square is 4, minus of minus is plus, 143 into 4 into 1 will give me 572 here. When I solve this, 572 plus 4 is 576 minus 2 plus or minus square root of 576 divided by 2. Now we know that square root of 576 is nothing but 24 here. We have two roots here. One is either one I'll do it by considering plus 24 and one I'll take it as considering minus 24. Therefore, x equal to, when I take 2 common from this again, that will be, when I take 2 outside, that will be minus 1 plus or minus 12 divided by 2. This 2 get cancelled here. Therefore, x equal to minus 1 plus or minus 12. Therefore, if I consider this as plus 12, that will be one solution, that is x equal to minus 1 plus 12, that will give me 11. If I consider 12 as minus 12, x will be equal to minus 1 minus 12 will be minus 13. Since it is given in question that it is odd positive integer, this has to be 11 here. Therefore, x equal to 11 is the first odd positive integer, and next consecutive odd integer will be x plus 2, that is nothing but 11 plus 2 is equal to 13. Hope you understood solving quadratic equation by this quadratic formula. I have tried to simplify it as easy as possible. Coming to the last subtopic of our video, that is nothing but nature of roots of quadratic equations. Let us understand what is the meaning of this. We know that roots of the quadratic equation of the form ax square plus bx plus c is equal to 0 are given by this formula, that is x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Now, while considering this formula I mentioned earlier, our roots will depend on this, that is b square minus 4ac term. These terms are nothing but coefficients of x square, x and constant terms. This formula is made up of those coefficients here. If b square minus 4ac is greater than 0, then we get two distinct and real roots. Means our roots will be different. Unlike we got when we solved one problem using what is method of completing the square method, you saw there that both the roots were same. But in this case, if b square minus 4ac is greater than 0, we'll get real roots and both roots will be different. They will not be identical. And how to calculate that roots? It is given by minus b by 2a plus b square minus 4ac divided by 2a. And one more will be, just replace this plus sign by minus sign. So these two distinct roots you will be getting when b square minus 4ac will be greater than 0. Next condition is, if we have b square minus 4ac, this term equal to 0, in that case we will get two real roots and they will be equal roots. Means both the roots will be same, exactly same. Means for example x equal to 2 comma 2, x equal to 4 comma 4, means same number you will have to substitute in order to arrive at the answer. That is obtained by b by 2a. If you can observe here, b square minus 4ac, if this value become equal to 0 here, then square root of 0 will be 0, then this entire term will become 0. Then only minus b divided by 2a will be remaining. Therefore, solution will be minus b by 2a two times. Now, third condition is, if b square minus 4ac is less than 0, if this term is becoming less than 0, that is nothing but a negative number. Square root of any negative number is does not exist, or it will be an imaginary number. Therefore, there is no real roots for the given quadratic equation in this case. Note, since b square minus 4ac determines whether the quadratic equation has the real roots or not, therefore what we can say that this term b square minus 4ac is called as discriminant of the quadratic equation. This question can be asked for multiple choice. Write the formula to calculate discriminant of a quadratic equation is dash, or you will be given with coefficient of x square, x and constant term, and you will be asked to calculate discriminant of that quadratic equation. So you should remember b square minus 4ac is called as discriminant of that quadratic equation. Conclusion: a quadratic equation ax square plus bx plus c is equal to 0 has two distinct and real roots if b square minus 4ac is greater than 0, two equal real roots if b square minus 4ac is equal to 0, and it has no real roots if b square minus 4ac is less than 0. This entire slide can be very important in order to solve multiple choice questions or one more 1 or 2 marks questions. So keep all these points very handy with you. Let us try to understand nature of roots of quadratic equation through examples, and let us look into some of the examples how questions can be framed on this concept. Example 1. Find the discriminant of the quadratic equation 2x square minus 4x plus 3 equal to 0. In order to get the nature of this roots of quadratic equation, first I will note down the standard form of quadratic equation, that is ax square plus bx plus c equal to 0. Comparing this standard form with given quadratic equation, I'll note down all the coefficient values. Coefficient of x square is a, that is equal to 2, and coefficient of x is b, that is minus 4, and constant term c is equal to 3 here. Now we know that discriminant is given by b square minus 4ac. When I substitute all the available values in this equation, it will be b square is nothing but minus 4 whole square minus 4 as it is, a value is 2 and c value is 3 here. When I simplify this, minus 4 whole square is plus 16. Be careful here. Minus 4 whole square is plus 16. Minus 4 into 2 is 8. 8 into 3 is 24. Plus 16 minus 24 is minus 8, which is less than 0. Now we know that for a quadratic equation of the form ax square plus bx plus c equal to 0 has two distinct real roots if b square minus 4ac is greater than 0, and two equivalent real roots if b square minus 4ac equal to 0, and it has no real roots if b square minus 4ac is less than 0. For the given example, we have found discriminant value which is less than 0, that is minus 8. Hence condition 3 holds good, this condition, that hence, 2x square minus 4x plus 3 is equal to 0 has no real roots, which means it has imaginary roots, which is out of scope of this chapter or this class 10. We are not going to discuss about that in this class. Now we'll take one more example to understand different type of questions asked on this concept. Example 2, which says find the value of k for the quadratic equation such that it has two equal roots. You can see here coefficient of x is not given. He has asked us to calculate coefficient of x if this quadratic equation supposed to have two equal roots. Now making use of this nature of roots by discriminant value, I'll first note down the quadratic equation in the standard form, and I'll note down given values, that is coefficient of x square a value is 2, coefficient of x, that is b is nothing but k here, and constant term c is equal to 3 here. Now I need to find this k term. We know that for a quadratic equation ax square plus bx plus c is equal to 0 has two distinct roots if b square minus 4ac is greater than 0. This condition is not applicable for our question. Now you can see that two equivalent real roots. If it is supposed to have two equivalent real roots, b square minus 4ac should be equal to 0. Therefore, I will make use of this statement. Using this statement, what I'll do is I'll substitute all the values in this here. In place of b, I'll keep k as it is. Therefore, k square minus 4 into ac. A is 2 and c is 3 here. When I simplify this, k square minus 4 into 2 is 8. 8 into 3 is 24. K square minus 24 is equal to 0. Or I can say k square is equal to 24. Therefore, k is equal to square root of 24. I can also represent this 24 as 4 into 6. Or I can write square root of 4, I can take it out as 2, that is nothing but 2 root 6. Means if k value is equal to 2 root 6, only then this quadratic equation will have two equal and real roots. For any other value of k, this quadratic equation will not have two equal real roots. Hope you enjoyed this video, and this is the With this problem, we have come to an end to this video. Hope it was very interesting, and I have tried to simplify quadratic equation chapter as easy as possible. And thank you for watching the video. In my next video, I'll come up with one more chapter from SSLC Mathematics. Till then, have a good day and stay tuned. Please like, share, and subscribe my channel so that you'll get all the notifications of the next upcoming uploads of my channel. Thank you once again for watching the video. Now you can also download the PPT for your reference as notes by clicking on the link provided in this video description.